Adding vectors in 2 dimensions is slightly more difficult, but definitely something we can do. First thing we need to do is define our directions. So if we, let's say we define our directions this way. We've got north, south, east, and west. Then, when we draw a straight line like that, well, that is in the east direction. However, if that line is not straight across, how do we define it? Well, we need to take a protractor that is parallel with the edge of the page, so you have to line it up parallel with this line or the edge of the page. In other words, you don't want it to be rotated slightly at all. You want it exactly level with the page. And with the line passing through the origin of your protractor, we can see that we are at approximately 24 to 25 millimeters there, or sorry, degrees. So I would say 24.5 degrees. So we can say then, if this line is line segment AB, we can say that vector AB is equal to, now we have to measure it, and I measure it to be, looks like 5 centimeters. Look at that, I got it dead on. So it is line segment AB equals, 5 centimeters. Now the direction. It was 24.5 degrees north of east, right? Because straight across would be east. And then we went 24.5 degrees north. So that would be written as, again, directions in square brackets, east 24.5 degrees north. Now, just type that so you can see it without my chicken scrawl. 5 centimeters east 24.5 degrees. Good question. We'll maybe try a superscript O. That should work. 24.5 degrees north. All right. Let's try another one. let's say we've got this one. Well, first we can measure the length of it. So we take our ruler, spin it around, line it up. And we see that it is 5.3 centimeters. And move our ruler out of the way. Oops. Bring our protractor in. Oh wait, sorry, first we need to define our direction. Just going to that out of the way. I'm going to go up here and just write so I don't forget that was 5.3, just so I remember. We need to define our directions now. So we always need to put in our little compass thing. And if you just put north like that, that's all you need to put. You don't need to put the other ones in, because everyone knows that this standard that if that up is north, down is south, to the right is east, to the left is west. So from now on in your questions, that's all you'll need to put in. So we know that it's 5.3 centimeters, but what is its direction? Make sure that the line goes through the origin. And have a look here. Looks like 29 degrees. Now that would be what? This direction is west, so it would be west 29 degrees north. So again, if this is A, B, then vector AB, vectors always have the line with the arrow over it. Vector AB equals 5.3 centimeters directions in square brackets was west 29 degrees north. So let's see if we can work out this example. So 3 centimeters east, 4 centimeters north. Again, we would put in our little crosshair here. I'm just going to copy and paste it to save us some time. Okay, our little direction meter, put that in. And then we know that, okay, 3 centimeters east, east is going to be to the right. So we draw in our line. Actually, I should pull this down a bit, make sure, because I'm going to be going north from here. So we draw our line 3 centimeters long in the east direction. And then we draw from the end of that one straight in the north direction. I can't quite get that straight, but close. So straight in the north direction, 4 centimeters. I went a little bit long there. Go. All right. Now remember that the resultant vector always is measured from the beginning of the first vector to the end of the second vector. So in this case, that would be from there to there. And we measure it to be, now we really should be drawing this vector in as well. So I'll maybe do that. No, that won't be red. 1 second here. Well, that's right, I'll use black. We draw our resultant vector, and we draw it accurately. We measure it to be 5 centimeters. Okay, so it's 5 centimeters long. And our direction is -53 by the looks of it. So our resultant vector in this addition is 5 centimeters that would be east 53 degrees north. And there we go. Now we've got vector addition in 2 dimensions. In the next video, we will do subtracting vectors in 2 dimensions.